Today we are going to learn about improper integral. So before learn about improper integral, uh, let us see what is proper integral. An integral a to b fx dx, an integral a to b fx dx is called proper integral if there are two conditions satisfy two conditions, first and second. So in first, the interval of integration interval of integration a to b is finite, and second condition is the integrand the integrand f is bounded on closed interval a to b. So for proper integral we have two conditions. First condition is about interval a to b should be finite, so it means a to b should be bounded. Let's say 1 to 2 fx dx, or anything which is bounded here, lower limit and upper limit, but we cannot take minus infinity to 0, or we cannot take 0 to infinity, or minus infinity to infinity. So in these three cases, one of the limit is infinity. So we cannot consider this because our interval of integral should be finite. Okay, so this is the first condition. Second condition, we cannot take anything which is unbounded. So if we consider anything like function fx is equals to 1 by x, and if we consider 0 to 1 fx dx, so in this case what happened, limit x tending to 0 fx, that is limit x tending to 0 1 upon x is does not exist. It means what? It means it is unbounded. So we cannot consider this type of functions. So integrand fx should be bounded should be bounded on closed interval a to b. This is second condition. So what it means? It means whenever we take the limit x tending to c fx, where c belongs to closed interval a to b, this limit should be finite. So if any integral a to b satisfy these two conditions, then we can say that the integral a to b fx dx is proper integral. So now come to the definition of improper integral. So what is improper integral? So integration a to b fx dx is improper integral. In short, we can say that any integral which is not proper is improper integral. So there were two conditions in proper integral. So if any of the condition is violate, then this integral a to b is called improper integral. So let's see, there are three conditions for improper integral. First condition is either the interval of integration a to b is not finite is not finite. It means what? It means we can take infinity to 0, or we can take uh, minus infinity to 0, we can take 0 to infinity, or we can take minus infinity to infinity. So in this all the three cases, we can see that one of the integration limit is not finite. One of the integration limit is not finite. So if any of the integration limit is not finite, then this is called an improper integral. Second condition is uh, if f is not bounded if f is not bounded on closed interval a to b. So let's see example. So suppose if we take 0 to 1 dx upon x, so here you can see that these two integration limit is finite here. But what happened? Fx is equals to 1 upon x. If we take the limit x tending to 0, fx becomes does not exist. This is does not exist. It means what? It means this function fx is not bounded. Okay, so this is the second case where we can say that the integral is improper integral. So any of these two condition is happening, then we can say that the integration is improper integral. Third condition is the mixture of these two conditions. So third condition is the mixture of these two conditions. It means what? Neither the interval, neither the interval a to b is finite, neither the interval a to b is finite, nor f is bounded, nor f is bounded. So these are the three conditions where we can say any integral is improper integral. If you want to see the example of the third condition, let's see minus infinity to 0, 0 dx upon x square. So here what happened? One of the limit is infinite, and if you calculate the limit at x tends to 0, 1 upon x square does not exist. This is does not exist. So this is the example for this third conditions. You can also construct more example like 1 to infinity dx upon x minus 1. So in this case what happened, one of the integration limit is infinite, and if you calculate the limit of this function fx is equals to 1 upon x minus 1 at x tending to 1. So this limit does not exist, this limit, this is does not exist. So this is the example of this third condition.